Now, as I say, acetylcholine is quite a rare neurotransmitter in the brain. Very few neurons in the brain use acetylcholine as their neurotransmitter. Okay, now the neurons which do release acetylcholine as their neurotransmitter, they are all located in a certain portion of the brain. They all have their cell bodies in special areas of the brain. Okay, so all the neurons which use this as their neurotransmitter are aggregated together into nuclei, basically. They all have their cell bodies in specific areas, and these nuclei that use acetylcholine are known as the basal forebrain nuclei, because they are at the base of the forebrain. Okay, some people will even call them the basal forebrain, and then you can insert in here the word cholinergic, because they use the neurotransmitter acetylcholine. Okay, now there are multiple basal forebrain cholinergic nuclei, but as I said, I'm only going to focus on one of them. I'm only going to show you the anatomy of one of them, okay, which is this nucleus basalis of Maynard, the NBM. This is the biggest of the basal forebrain nuclei. The others are all sort of clustered around this one. Okay, right, so let's discuss the anatomy of the nucleus basalis of Maynard then. Okay, and that will help us to illustrate what the function of these cholinergic nuclei are. Okay, so we're going to go back to showing the hypothalamus from the left-hand side. So effectively, I'm going to go back to this picture here, and I'm going to look again at the hypothalamus drawn from the left-hand side. Okay, right. So here is the hypothalamus viewed from the left-hand side. Here's the optic chiasm again. Here is the pituitary stalk with the anterior and the posterior pituitary here. Then you have the mammillary body back here. Okay, so that's the hypothalamus. And we won't draw the portions behind that. Now I'm going to add on another structure onto this picture. I'm going to add on a structure that lies above the hypothalamus. Okay, now this is not yet the nucleus basalis of Maynard. Instead, this structure here is a bundle of axon fibers that moves in this sort of direction. Okay, so it's going into the page in the direction that my pen is moving. It moves over the top of the hypothalamus, and it's going to travel from one temporal lobe, the left temporal lobe here, to the right temporal lobe that's on the other side. Okay, so what is this special bundle of fibers that is above the hypothalamus here? What's known as the anterior commissure. Okay, now this is a good landmark for understanding where the nucleus basalis of Maynard is. Now before I put the nucleus basalis of Maynard onto this picture, I'm firstly going to draw this picture from the other angle so that you have a very thorough understanding of what the anterior commissure is. Okay, so if I view it from above again, okay, so here is the hypothalamus again, viewed from above, okay, and remember it just makes up the wall with the third ventricle sitting in the middle here. Okay, now the anterior commissure then is going to be this bundle of fibers moving over the top of the hypothalamus here. So this is the anterior commissure here. Okay, right. Now let me show you where the nucleus basalis of Maynard is on this picture. Now the first thing to say is that you have two nucleus basalis of Maynards. Okay, you have a left nucleus basalis of Maynard, and you also have a right nucleus basalis of Maynard. Okay, and I think I'll show them on this picture first, so let me just extend the anterior commissure a little bit. Okay, so here we go. Now, the nucleus basalis of Maynard's then are going to be underneath the anterior commissure, sitting on either side of the hypothalamus. So they're going to be under the anterior commissure on either side here. Okay, so I will just colour in the sides of them that are peeking out from underneath the anterior commissure there. Okay, because they are underneath the anterior commissure. So if I show them on this picture, they're going to be sitting, well, we're only going to be able to see the left one here, because we're looking from the left-hand side, but here it is sitting underneath the anterior commissure there. Okay, so this is the nucleus basalis of Maynard, the left nucleus basalis of Maynard, and then we've also got the right nucleus basalis of Maynard. Okay, right. Now, what then is the function of these basal forebrain nuclei? And again, I'll stress, I've shown you two here. Okay, the two nucleus basalis of Maynard's. There are other basal forebrain nuclei as well, which are in a similar location to this. Okay, so what is the function then of these cholinergic nuclei? Well, basically, they are going to send their axons out from this area. This is the area where all of the cell bodies are located, but they're going to be sending their axons all over the place, okay, to supply the cerebral cortex with acetylcholine, basically. And this acetylcholine is believed to have a broad regulatory function, basically. The nucleus basalis of Maynard is releasing acetylcholine all the time onto the cerebral cortex. Now let me just show this in another picture. Okay, a little picture that I'll put here. So if we now draw a sagittal section of the brain, so I'm going to draw you the right one. Okay, so we've opened up, split the two portions of the brain apart. Okay, so here is the front bit. Okay, and then we're going to have the right temporal lobe here. Okay, then you're going to have the right half of the brainstem, so here is the right half of the pons here. Then you'd have the right half of the medulla below there. Okay, then you'd have the midbrain here, the right half of the midbrain. Then you'd have the right thalamus sitting on top here, and then of course you're going to have the right hypothalamus here. Okay, with the right half of the optic chiasm, the right half of the pituitary stalk, the right half of the pituitary, the right mammillary body, and there we go. Okay, now I'll just finish up the back here. Okay, so finishing up the back, you get something like this, and then here is the right half of the cerebellum right at the back there. Okay, so putting then the right nucleus basalis of Maynard on, it would be behind this portion of the hypothalamus that we can see here, but I'll draw it there. Okay, there it is, sitting behind the hypothalamus. And what's going to basically happen is it's going to be sending out axons, okay, which are going to be taking this sort of a path, okay. And some of the axons will, this is a huge great bundle of loads of axons, not just one axon. Okay, and off this bundle will be coming loads of different axons at different points. And they will be going to the cerebral cortex of the right cerebral hemisphere here and supplying it with acetylcholine. Okay, so they're releasing acetylcholine onto the cerebral cortex, basically. And then, of course, the left nucleus basalis of Maynard will be doing the same thing, basically. Okay, right, so what then is the broad function of this? Well, it's believed that acetylcholine dictates how functional your cognitive abilities are. So you know that sometimes your brain is working fantastically. You can calculate like that. You can solve problems like that. You can talk and understand language like that. Okay? You can visualize in 3D really easily. And then at other times your brain isn't working so well. So for instance, when you're about to go to bed, when you're really tired, your cognitive ability is not particularly great. Okay? Why? What's changed? Why is your cerebral cortex functioning less well? Well, it's believed that it is the acetylcholine transmission to the cerebral cortex that determines how functional it is, how much it's working, basically. Okay, so when acetylcholine is high, okay, and you're releasing lots of acetylcholine onto the cerebral cortex, your cerebral cortex is going to be functioning fantastically well, okay, and you're going to be able to do a huge number of cognitive tasks easily, basically. Okay, when your nucleus basalis of Maynard's and other basal forebrain nuclei are not releasing that much acetylcholine onto cerebral cortex, maybe because you're just about to go to bed, then your cognitive abilities will be low. Okay, your cerebral cortex will not be functioning as well, and your cognition will not be as good. Okay, so in early Alzheimer's disease, what happens is these basal forebrain nuclei degenerate very badly, okay? Just like the hippocampus and the entorhinal cortex, they are particularly sensitive to Alzheimer's disease, and they are one of the first areas to go, okay? And this is believed to underlie the cognitive symptoms of Alzheimer's disease that occur early on. So basically, in Alzheimer's disease, initially, you feel just as though you're always about to go to bed, or, well, your cognitive ability is as though you're always about to go to bed. It's always in this sloppy sort of state, basically. Okay, now I want to stress that that is in the early stages of Alzheimer's disease. Later on, when the cerebral cortex has degenerated, then the cognitive deficits are no longer merely due to the lack of the cholinergic basal forebrain nuclei. Okay, but in the initial stages of the disease, the cognitive decline is believed to stem from the degeneration of the basal forebrain nuclei, which control how turned on your cortex is, effectively, how functional it is, and how high your cognitive abilities are therefore running, basically. Okay, right, so those two little areas are particularly affected then by Alzheimer's disease, and they underlie the symptoms of the early disease. Later on, it unfortunately just spreads and all of the brain starts to degenerate, and that underlies the dementia of the later stages of Alzheimer's disease. Okay, right, so we'll call it there for this video, and in the next video what we will move on to is discussing the biochemistry of the neurodegenerative process. Okay, so we will discuss amyloid precursor protein and how it can be cleaved.